Hey, good afternoon, folks. Welcome to Balluff's third edition of Total Error Prevention. The first two presentations, we covered identify trouble spots, and that was really a task that we needed our customer to identify for us. And then in our second course, we covered the implement detection. So today, as part of the total quality management circle, we're going to focus on contained discrepancies. So within that, traceability and tracking is critical to overall error prevention. And so if we look at traceability, what is that? Well, we want to contain information in our tracking and traceability as far as build information. So what's the bill of material? What should be built that's part of that bill of material? And we need to understand the process information. Here we're saying, how did it go? So were the correct components available and assembled onto that sub-assembly part? Were all the proper parts correctly installed, or were there pieces missing, or they were partially installed? And then we want lineage information, what was used through the whole manufacturing process. So we're able to contain or have all the data through the entire manufacturing process. So those are the three key factors of traceability that companies want to know in a linear automated manufacturing environment. So let's look at that. If we're looking at the build information, we're going to want to know what the bill of material is, which we've commonly heard the term BOM. So we need to know the entire build data of a assembly that's being manufactured. Flexible manufacturing requires build sheet held in each data carrier. So if we look at the image that's shown to our right, we can see where my arrow's pointing at a build sheet that's affixed onto a carrier as it moves through each different manufacturing line. And if we look at the product that's being built, which are instrument panels, we can see that there are different models that are on that common assembly process. So this is a great example of a true flexible automated assembly line. Here we see a beige instrument panel, and right in front of it is a black instrument panel. From that bill of material, what needs to be determined is what went wrong, and that information be logged onto that build sheet. So that would now carry process data. So continuous conveyor requires error-proofing data to be held in the data carrier for use in rework lines. So if there are problems, if the product is flagged and goes back to rework, then the rework operator would pick up that sheet and identify what is missing or what is the problem and make the appropriate changes. So that in mind, if we now look at the image to the left, we can see a Balluff read-write head, and underneath that is an RFID tag that would be affixed to the carrier. By using RFID, we're essentially able to eliminate the requirement of this handheld sheet that's affixed to the carrier. So the build data can be all contained into that RFID tag, and at each station where we're doing error checking, we can confirm or flag what errors have occurred so that we're not doing further value add to a defective piece, and it can be routed directly to the rework station. So containing product discrepancies, we want to be able to determine whether we're going to have to scrap a part that's being assembled once it gets into the rework station, or we need to know whether we can reclassify the part. So maybe a an incorrect clip was put on, so instead of it being for a right-hand door, maybe it gets reclassified to be part of a left-hand door. Or we are able to rework the part. So by having all of this data tied to the workpiece really helps simplify and increase the efficiencies of manufacturing and avoid any escapes of a defective part being sent off to the end customer. So the build data, historically, build data was done on a piece of paper or a ticket. By having the information now on an RFID tag, that really renders well to a true flexible manufacturing environment. And if we think about it, in Canada, most of the manufacturing now is not so much anymore high volume, low mix. More and more manufacturing in Canada is more about custom manufacturing, where we're having high mix and low volume. So the importance of being able to change manufacturing process, determine what value add is done on each workpiece becomes more and more important. RFID is an ideal tool for our customer to use in that type of manufacturing or flexible manufacturing environment. Here we're talking about taking control of a rework area. They're speaking about locking out areas based on traceability information. So if we look at this example, we have a part that looks very common here in the bottom right corner, but clearly the color of the one component is white as opposed to black. So if there are, with this torque gun, there may be different sequences of assembly done between a white assembled part and a black assembled part. Having the ability to identify what part that is can be you can have the torque gun prevent the operator in doing some sub-assembly on certain areas. So now we look at lineage data. What's becoming more and more important is understanding what components have been assembled at the source of manufacturing. So this has become critical for areas where customers need to recall their product. They want to be able to limit their liability claims and ensure that regulatory compliance is followed. It's having traceability in RFID actually becomes an asset to our customers, where they can actually prove that they have done all the correct assembly and the correct process at each different station. So it becomes a tool to mitigate any liability issues that they could be presented with at any given time. So here we can see an example of a pump where lineage data is being stored on the tag. So that pump has many different components and sub-assemblies being added to it. You'll want to make sure that those parts have been, and the correct parts have been installed, the proper torquing has been installed on the product, and all of this data can be stored onto a tag to prove to not only our direct customer but their customer that the part has been assembled correctly. So let's look at some of the tracking systems that are available. There are a fixed tracking system we see in the image in the top right-hand corner, where we have a fixed RFID read-write head and a fixed tag. So the advantage there is, this is a more preferred method, and that it's certainly a more economical option, and we're ensuring that the tag and the read-write head are consistent in their mounting and how the tag is being presented in front of the read-write head, so we can ensure that we're getting proper transfer of data to and from the RFID tag. But not in all cases is having a fixed device practical. In some cases, customers require a handheld device, and we do have handheld RFID devices, and that gives the operator the flexibility of being mobile to read and or write information to and from the tag. But we have to make sure that care is taken to ensure that the proper information is being read or written to and from the tag, the correct tag, by the operator. So there needs to be a little bit more care taken in that regard. Balluff has, at least in this presentation, we're going to focus on low frequency and high frequency solutions. So we have handheld devices that are equipped with different software options. So we have what's called template software and portal software. And this is a big differentiator of Balluff from the rest of our competition. For example, if we looked at our portal software, this gives the customer the ability to display and query RFID and barcode data the way the customer wants. It means that there's no extra programming or integration required on the part of our customer. It allows customizable data to be displayed. It's done in a simple display configuration. So we're able to read the information in the desired engineering units that the customer wants to read, rather than being in ASCII or binary or hex. We're able to get that into the true engineering units that the customer knows and understands. In low frequency and high frequency, we have two families, the L system and the M system, and they cover a wide range of applications. There's a huge selection of different types of read-write heads, different capabilities and reading only or doing both reading and writing, and there's large selection of different types of tags depending on your customer's application. So that kind of completes the whole cycle of total quality management. Again, we identified the trouble spots that the customer was able to share with you and us as Balluff. Then together, between us and our customer, we're able to implement the correct detection method, and then we've just now defined the methodology of containing the discrepancies.